Here's the answer key for the second half of Integration and Accumulations study guide. Our first problem, we see the integral from 0 to 1 of x times the quantity, the square root of 1 plus 8x squared. This is our classic u substitution problem. So u is going to be our inner function, 1 plus 8x squared. That makes du 16x dx. We're obviously missing the 16, so we'll get a 116 on the outside, and that allows us to put the 16 on the inside. So now when we do our u substitution, we have the square root of u du. As we know, the square root of u is equal to u to the 1/2. So when we take our antiderivative, we're going to have the 1/16, and then it will become u to the 3/2 over 3/2. Now we have a definite integral, so we have our bounds as well. Remember, we have to change our bounds when we change our variable. So the bounds were 0 and 1. So u of 0 would be 1 plus 0, and u of 1 would be 1 plus 8, or 9. So our new bounds are 1 and 9, and we've got that as well. All right, now we have to plug in here. It gets a little crazy with the fractions and the division by fractions. We know that if we're dividing by 3/2, then that is the same thing as multiplying by 2/3. So we have 1/6 times 2/3. And that would give us our 2 over 18, or 1 over 9. Whoops, I'm sorry, not a 6, a 16th. My apologies here. So let's try that again. 2 over 48, or 1 over 24. Okay, so we have, let's see if I can squeeze it in here. We have 1 over 24, and then this is u to the 3/2, so we know that that would be the square root of u cubed. And this is being evaluated from 1 to 9. So we have 1 over 24 times the square root of 9 cubed minus the square root of 1 cubed. 9 cubed is 81 times 9, or 729. So 729 under the square root over 24 minus square root of 1 over 24. I'm running out of room again, so I'll drop down here. The square root of 729 is 27. So we have 27 over 24 minus 1 over 24, which is 26 over 24, which simplifies to 13 over 12. Problem number 2. So we have this function f, which is the absolute value of x divided by x if x is not 0. However, if x is 0, then the function is equal to 0. So if we do a quick graph of this, and we're interested, we can see from -5 to 3. So we'll put -5 over here and 3 over there. So we can see here that if we have, for example, -5, we'll have the absolute value of -5, which is 5, divided by -5. 5 divided by -5 is -1. So our graph will be equal to -1 if x is not 0 and less than 0. However, if x is greater than 0, like up here, for example, the 3, 3 divided by 3 gives us 1, so our graph would just be 1 when x is positive. And then it goes through that point right there. All right, so we're trying to find this value. We know that this value will be the area between the function and the horizontal axis. So it's that rectangle and that rectangle. Obviously, this is a base of 5 and a height of 1. This is a base of 3 and a height of 1. But we have this 5, we need to make it negative since it's below the x-axis. That should be a plus sign. There we go. And so we can see -2. For number 3, we have this derivative equal to -10e to the negative t over 2. And we have an initial condition that y of 0 is equal to 20. And we have to find y of 6. All right, so there's a couple ways to go about this. If we go with the whole new value is equal to the old value plus all the change, then we'd be looking at y of 6 is equal to y of 0 plus all of the change from 0 to 6 of that derivative there. So -10e to the negative t over 2 dt. You could also just take an antiderivative, have an arbitrary constant, use this to solve for the arbitrary constant, and then you now have y of t, and you can find y of 6. So again, there's multiple ways to go about this. So moving forward here, we have 20 minus 10 times the integral from 0 to 6 of e to the negative t over 2 dt. So again, a little u substitution here. Right? U would be equal to -t over 2. du would be equal to -1/2 dt. We don't have the -1/2, so we would need to put it in there. And we need to put the corresponding -2 out front. We already had a -10 there. Now we're multiplying by -2. So we now have 20 plus 20 times the integral of e to the u du. Our bounds were 0 and 6. If we plug them in, then we are looking at u of 0 being equal to 0 and u of 6 being equal to -3. So we now have 0 and -3. Our bounds are backwards, so we will make this 20 minus 20 times the integral from -3 to 0 of e to the u du. E to the u antiderives to itself, so we now have 20 minus 20, and then our e to the u being evaluated from -3 to 0. So 20 minus 20, and then we'll have e to the 0 minus e to the -3. Right? E to the 0 is 1. So we now have 20 minus 20 times 1 minus e to the -3. We can distribute the -20. So we have 20 minus 20 plus 20 e to the -3. And we can see that the two 20s out front will eliminate each other, which means that our final answer is B. And finally, number 4 is pretty tricky, more tricky than anything you'd see on the quiz, but let's take a look at it anyways. We do have this inner function, so it would make sense to make u equal to that. So let's make u equal to e to the x minus 1. If we take the derivative, e to the x derives to itself. 1 obviously derives to 0, so we have e to the x dx, which happens to be exactly what we see right there. So we have the integral. We're going to have in the denominator 1 plus u squared, and in the numerator is du. Our bounds, we have to change them over, so we need u of 0, which will be e to the 0 minus 1, or 0, and then u to the first power, u to the natural log of 2, it's actually going to be e to the natural log of 2 minus 1, which is 2 minus 1, or 1. So our new bounds are 0 and 1. This second trick here is to look at this and see that this is in fact going to equal arctan. This is the derivative of arctan right here. So when we take the antiderivative, we get arctan of u, and that's being evaluated from 0 to 1. So we have the arctan of 1 minus the arctan of 0. So now we have to go to the trig chart, and we need to remember what the tangent, when the tangent is equal to, of an angle is equal to 1. All right, and the tangent of pi over 4 is equal to 1, so the arctan of 1 is pi over 4. The tangent of 0 is equal to 0, so the arctan of 0 is equal to 0, and our answer is C.